Hey guys, Mr. Milton here. Today we're going to talk about multiplying binomials. At the end of this video, you should be able to multiply a binomial by a binomial, and you should be able to multiply a binomial by a trinomial. In the last lesson, we learned how to multiply a monomial into a polynomial, mono 1, into a polynomial, and today we're going to be multiplying two binomials together. So, to do this, we need to multiply each part of the first binomial, which is 2x plus 3, here, 2x plus 3 times x plus 4, by each part of the second binomial, x plus 4. That means we have to multiply, or we have 4 things to multiply together, 2x and 3, and x and 4. And I'll show you two ways to do this. I really don't have a preference for either one. You can choose whichever one. You'll see their benefits and flaws, I guess. So the first method is FOIL. Okay, and this is the acronym that represents a process for multiplying. Okay, it only works when you're multiplying two binomials though. So if you have a trinomial, if you have more terms, the FOIL might not be the best method. Well, sorry, you won't be able to say FOIL to show you your process. So, FOIL means firsts. You will multiply the firsts numbers of the binomials. So in this example, 2x is the first in its parentheses, x is the first in its parentheses. This reminds you, do the firsts. Then, O stands for outsides. Okay, this tells you, multiply the two numbers on the outsides. So 2x is on the outside, 4 is on the outside of the parentheses. Okay, so it reminds you, do 2x times 4. I stands for insides. Okay, the two numbers on the insides. Multiply those together, 3 and x. And then lasts. Okay, this tells you multiply the last numbers of each parentheses, 3 and 4. Okay, so when we multiply those together, 2x times x gives us 2x squared. 2x times 4 gives us 8x. 3 times x is 3x, and 3 times 4 is 12. So that's our first step. Our first step is to multiply each pair of terms together. The second step is to add like terms. Remember, when we say like terms, that means terms that have the same variables to the same exponents. So as we look, 2x squared, 8x, 3x, 12. Well, these all have x's, but this is x squared, so it's not like. These two are our like terms. Positive 8x, positive 3x. We add those together. That gives us 11x. And so we'll write our product in standard form as we will all of our answers. 2x squared plus 11x plus 12. And that's our answer. Okay, so that's the FOIL method. Now with all the methods that I show you, you're going to get to the same answer no matter which method you use. Okay, so if you remember our systems of equations chapter, we learned 3 methods to solve the same problem, but all of them should get you to the same answer. Same here. When I show you the box method is only different in how you set up basically your process, but it should be the same thing in the end. So as we look, we have 2x plus 3, we have x plus 4. Notice how we separated these things. We have 2x and then plus 3 in our second box, x and then plus 4 in our second box. We wrote one binomial horizontally and one binomial vertically. So we have 2x times x, gives us 2x squared. So in each box, we have the product of the two things that meet there, almost like a Punnett square. 3 times x meets here, 3x. 2x times 4 meets here, 8x. 4 times 3 meets here, 12. And so it helps us to remember, hey, we have to multiply all four of these things. Again, we'll find our like terms. Typically, if you write your binomials in standard form, your like terms will be here, if they're anywhere. And then we add them together. So 2x squared plus 11x plus 12. And like I said, no matter which method you choose, whether you choose box method or FOIL, you should get the same answer if you do them correctly. Okay, back here get some options, and I want you to multiply using either method. So pause it, try it out, and when you unpause it, I'll show you the answers. So we have x plus 5, x minus 2, so we can FOIL if we wanted to. Firsts, x times x squared, outsides, x times negative 2, which is minus 2x, insides, 5 times x, positive 5x, and lasts, positive 5 times negative 2, negative 10. Okay, so there's my multiplication for my FOIL. I'll find my like terms. Again, they're here. And so I'll put those together. Negative 2x, positive 5x. That gives us 3x. So we have x squared plus 3x minus 10. Now whether you did this by the FOIL method or the box method, you should get this answer. I'll show the second one with the box method. Okay, so you make a box, 2 by 2, because they're binomials. So I have 3x and minus 2, 2x and minus 1. It does not matter which one you put on top and which one you put written vertically. It really won't change it. Okay, so 2 times 3 is 6, x times x is x squared, negative 2 times 2x is negative 4x, 3 times negative 1 is negative 3x, negative 1 times negative 2 is positive 2. Okay, my like terms are here, put them together, and so I have 6x squared minus 7x plus 2. Okay, so either method works if you did FOIL for the first or box for the second. Don't worry about it. If you'd like some extra practice, you could try to do it the other method with these answers in place so that it can help you out as far as doing those. Okay? Alright. One more example we're going to go through is multiplying a binomial by a trinomial, and then we're going to stop here at trinomial, but you can do it with as many terms as you need. So, when we're multiplying a binomial by a trinomial, which of the two methods described on the first page does not work? And that answer is FOIL. And not FOIL in like how we did it, but it won't remind you to do first, insides, or first, outsides, insides, last the same way because, well, there's 3 terms in one of them, so that won't get all the pairings that you need. So we can choose the box method. We don't have to, but we're going to choose the box method. Okay, so with our box, what we're going to do is we're going to make it the same dimensions as our polynomials. Trying to give myself enough space. So there's 3 terms here. I'm going to, yep, did that uneven. Okay, and then there's 2 terms here. So I have 2n squared, n, and 7. And then here I have 6n minus 5. And again, I'm just going to go through and write the product in each square. Okay. And then I want to go through and add my like terms, or put my like terms together. So I usually like to circle those and identify them before I start anything. Double check that I didn't miss anything. Okay, so here we go. That's going to be 37n and this is going to be negative 4n squared. Okay, and so now I'll write my final answers here. 12n cubed minus 4n squared. Sorry, that's positive. 37n and negative 35. Okay. Now, although I said you can't use FOIL, if you love FOIL and hate the box method, then what you can do is FOILing is essentially just making sure that you distribute your term to everything in the other box. So you could say, okay, I'm going to distribute 6n to each term in the other box and write those products. And say I'm going to distribute negative 5 to each term in the other box and write those products and add your like terms together. Okay, that's essentially what FOILing does. So just exposing you to that if that's something that you like way more. Okay. All right, our last problem is a little bit of a challenge problem, but I assure you, you will see this again. So get used to it, understand the thought process, make sure you're able to do this. So let's find the area of the shaded region. Give your answer in terms of x. Basically, this means, hey, it's not going to be a number. It's not just going to be like 17. Okay, you're still going to have a variable in the end. Okay, so find the area of the shaded region. These are rectangles. We should be able to find the areas of a rectangle, base times or length times width. And so we have to try to find a plan. We have this big rectangle that's shaded, and the small rectangle inside it that's not shaded. So if they want us to find the area of the shaded region, what we are going to do is we're going to say, okay, what's the area of this big rectangle? Okay, and so I'll kind of draw the picture of it. We're going to find the area of the big rectangle, big shaded rectangle, and then we're going to say, okay, but let's take away this spot. So we're going to subtract the area of the small rectangle. And then the answer to this subtraction problem should be the answer to the area of the shaded region. So we'll find the area of the big one. We've got 3x plus 2 and 2x minus 1. So I'm going to do FOILing here. I'll label my stuff so I can tell the answers or my work later when I'm looking back at it. So 6x squared minus 3x, and I have 4x, positive 4x, minus 2. I stack my like terms on top of each other, so I have 6x squared plus x minus 2. Alright, for my shaded one. Now I need to find the area of the unshaded box. So I have x plus 3, that's one side, and x minus 1 as my other side of the box. X times x is x squared, 3 times x is 3x, x times negative 1 is negative 1x, and 3 times negative 1 is negative 3. Adding my like terms together, I have 2x. So, subtracting x squared plus 2x minus 3. Okay, so now remember from our last lesson, or one of our previous lessons, is that we really don't like doing subtraction problems. What we'll do is we'll make this an addition problem. So 6x squared plus x minus 2. I'm going to change all these signs. So negative x squared minus 2x plus 3. Because I changed all these signs, now I can just do what it says to do. Gives me 5x squared minus x plus 1. Oops, I almost forgot my squared. Again, once we get down to this point, like terms are terms that have the same variable to the same exponent. These two would not be like terms because they both have x, but this one has x squared and this one does not. Okay? Alright, that's multiplying binomials and trinomials. Box method, FOIL, find a method that you like and stick with it. Typically, I will not demand that you use one or the other method. but you need to make sure that you get comfortable using either one. And I will caution you that drawing a box isn't so much more work that it's worth risking missing the process because you don't want to take the extra time to draw a box. Okay, so box method, FOIL, both great methods to multiply binomials. You can think of FOIL as distribution if you run into anything other than that. See ya.